You do need to learn the identification test for certain ions. When studying group 7 compounds, we learned how to identify halide ions. Halide ions give precipitates when aqueous silver nitrate is added. If chloride is present, the precipitate produced dissolves in dilute ammonia. If bromide is present, the precipitate does not dissolve in dilute ammonia, but will dissolve in concentrated ammonia. The precipitate produced with iodide does not dissolve in either dilute or concentrated ammonia. We learnt when studying acids and group 2 metals that when an acid is added to a carbonate, you get carbon dioxide released. Carbon dioxide can be confirmed by bubbling the gas through lime water, which is aqueous calcium hydroxide, and if the water goes cloudy, carbon dioxide has been produced. You first had hydrochloric acid, followed by barium chloride. If sulfate is present, you will see a precipitate of barium sulfate. Compounds containing the ammonium ion, NH4+, will evolve ammonia gas when treated with aqueous sodium hydroxide and then heated. The presence of ammonia can be confirmed by holding damp litmus paper over the mouth of the tube, where it will turn blue if ammonia is present. If you have a solution that you would like to run through these tests, you must perform them in a certain order. You must first test for the presence of carbonates before proceeding to test for sulfates, since when the barium chloride reagent used in the test for sulfates is added to a solution containing carbonates, a precipitate of barium carbonate will form, which will lead to a false positive for sulfates. Similarly, you should exclude the presence of sulfate before proceeding to the halide test, as sulfate compounds will form silver sulfate, which is insoluble and will lead to a false positive for halide ions. Generally, the order for testing a solution is carbonates, followed by sulfates, followed by halides.